Hey guys, welcome back to image processing tutorial. I know it's been a while since I came to here with another episode. So I'm sorry for that. So let's begin. I think today we're gonna see what a histogram is and how we can implement histogram with C++. So what basically an histogram is? So histogram is an picturization of the frequency of occurrence of some values or pixel values. So generally it's some values in a data pool. For in our case, for an image, if there are a lot of pixel values are there, and most of the pixel values are same. Like if we have a white image, it might have some 255 values, a lot of 255 values. For look at this image itself, there are a lot of 256 values and some blue values are there. So basically if we look at the frequency of occurrence of pixel values, we can see that white values might be very high and some blue values will be there. So we can look at some example over here. Look at this image, it has a major portion in white. So you can see that around some pixels are crowding around this. So we can, from this itself, we can say it's the grayscale of this image. We can see that some pixels, some values are around, some white values are there. And if you look at here, we can say okay, also some black values are there, isn't it? So this is what we can understand from this histogram of an image. We can basically put image into some place, like what image looks like. If the image histogram is like this, most of the values are around this region, so we can see that there has been some light over then also we got a shadow of the image. Basically our image consists of shadows. That way we can, like that we can process our image without even looking into the image, just by looking into the histogram of the image. So basically histogram is the graph showing the frequency of the occurrence of pixel values in an image. So now we're going to see how we can implement this histogram in C++. So in the earlier tutorials we had started an image processing library. So we'll start from the first we stopped it. So we'll write the histogram, we'll put in calculate histogram function, calculate histogram. Also as per our conventions we have some char for that we pass the value of the image, that which is the file. Those things will be left here. So first of all we need to have what we say, we need to get this image. Like when we start, we need to know what kind of image it is, whether it is an RGB image or something like that. So we need to put some flag bool flag band is equal to false. Okay, also we have to make sure we put this calculate image in here. Just put it over the sorry, we'll put it over the place. Yeah, so that's cool. So we'll put it like this, and if condition, if this dot number of bands equal to 3, that means it's an RGB image. So then we say, oh I'm sorry, I already had, okay, and then we say that flag band is true, flag bands equal to true. So else it's false because it's already given it out there as a default value. If flag bands is true, then we say we have to start making the histogram. We have to calculate the histogram. So if this is an RGB image, so we say we take a for loop. In the for loop we say we have to get the actual number of pixels there, not the number of, actually we have a height into width of the image. From that we have to count it. Then actually we have this number of bands into height into width as the total number of pixels, but we just want total height into width for this calculation. So we put it as total no, this not total pixel, this total pixels divided by this number of bands, and also we change this I plus plus. Also we'll just declare an ing or a int I comma j, and that will be enough. Also for here we say another loop, for loop, and this time we say number of bands, this number of bands. Oh, it's j, change to j. So now we put the histogram, like we have to get an place to store the histogram values. So what we're going to do is we just go here, and also we will put some histogram over here. So histogram, an array to store the histogram. Okay. So we say this dot histogram equal this dot image, and from that the which value I star, this not number of bands plus j, that gives the actual value the value of this histogram over there. So plus 1 plus equal to 1, and but there's a problem here. We haven't given the space for this histogram. So what we're going to do is we'll just allocate the memory space for histogram, that we shall do here. It's not histogram, histogram equal to unsigned car star and malloc. This one's space. I'm sorry. So the number of values, it's this high value. High value is the total length of the histogram, as you saw out here. Look at this. High value is here. Suppose we can say it's 255. So the high value is the highest value of the pixel. So highest value of the pixel is the length of the histogram. So we put it as high value into number of bands, because if it is an RGB, we have to allocate three values memory space for each pixel. That's why it's number of bands over here. So that's why we have given the allocated memory space, and we put it as 0. Now we are just mapping that each pixel values as number of pixels in corresponding to one value is in the increases, the frequency also increases. That's we have given here. And after that, if it is not the case of this flag bands, and if it is not case of 3 components, if it is not RGB, then we want to do the same. We have to put another for loop here. Again, it's the total pixels by number of bands is same. So this dot where to go? Sorry, this dot total pixels, and we change here, and this. Okay, we say this dot histogram, this dot histogram of values in this dot image of file, because we don't need this number of bands or thing, because it's already number 1. So plus 1, we also record that. Also, now we have made a basic histogram, but there are some problems. For visualizing this histogram, we need to plot it. So how we can plot it? The problem is when you are plotting it, if you can see here, Actually this blue component has got a big frequency and others don't have, but still we have to include this blue component in our histogram. That's so we have what we have to do is we have to put something like this. We have to find which is the highest frequency in the histogram. So we need to find it. For that we have putting some high value. We will define something like that. So getting high values, we say high value among red component, high value among green component, high value among blue component, and high value among gray component, and also one high value among RGB component. That's it. Okay, that's fine. So we say that when if it is the case of we have to find high, which is high. So initialization, we say HR equal to this dot image highest value number of values. This is the first pixel value is the highest value. It's just logic. You can understand what it is. Image of value 1. Oh, I'm sorry, it's HR1 HG RGB. So HB equal to this dot image of 2. So basic initialization is done there. So we have to, for the gray component also, we have to give the initialization. So we have to give something like this: HGR equal to this dot image of 0. Now we have done that. We have to find which is the highest value. So up here we again say if flag bands, and we say we start a for loop and searching for which is the highest value, and this dot high value, we search over the length here. This is the way our along the length we go, our loop will proceed. So high value, so we do it. And we say if there is an if condition, and if this dot histogram of values I star the number of bands. So number of bands, because it's the way it just goes around, is number of bands is greater than HR. HR, then we say HR equal to this dot. So we say if some of the values histogram corresponds to high values, so we say okay, this is the highest value pixel, and this goes for the blue and green components page. So we say it's RG, and we say +1. Also this goes to G, also this goes to B, also this goes to 2 and +2, and also this goes to RGB. Okay, fine. So we compare which is the highest one. Also if we have to now compare which is the highest among HR, HG and HB. So what we're gonna do is, if condition is there, if first of all we say HRGB equal to HR. We supposing HR is the highest one, and if HRGB is less than HG, suppose it might be less than the, so in that case we will check one more condition. If it is so, then you have to find which is highest among HG and HB. If it is HG is less than HB, then HB is the highest one. HRGB equal to HB. Else we say HRGB equal to HG. Green is the highest component, and if that's not the case, if HRGB is less than if HRGB is greater than HG, so we say you have to check whether HR is less than HB. If it is less than HB, then HRGB is HB, else it's HR. This HR is HRGB. Basically, it's also implicitly it is given here, so we need again give a if else condition. Also, we have to do this for the gray image. So we basically and we say just the if case, yes, else we say we start the for loop here, we just put this for loop over here. Here is the higher, this is not high value I plus plus. We say if we say if this was histogram of I, this not histogram of I is greater than HGR. That's the process that we did over there. In that case, HGR equal to this histogram of I. So I think that that's done over them. So now we also have to find which is the highest among, like we have the highest values among HGR and HRG, but we haven't communicated that high frequency value with the basic class. So we need to communicate that the basic class. We have to put a variable over here. We say something like high histo, which has the high, which stores the value of highest histogram. So what we say is if flag bands means if it is an RGB, in flag bands, then this node high histo equal to HRGB, else this dot high histo equal to HGR, because it's gray. Now basically we have the dimensions of the image histogram. Now we have to put that to a file, as we have to print it. So I am planning to put that as a file, as an image file itself. So how we can do it? So basically for putting image, we have the method here. We have the image processing library. So we'll put its own value, like image processing of M. Image processing M. This is the variable. Often this is an image variable. So we can print that to a file with this thing. So before that also our base class should know what's the highest, like also have this this what I say, also have this our image, the basic image that we want to pull into the image to a computer. So for that we have to put an out image. So out image histogram, image histogram over here. So and we say suppose out image histogram has to be initialized. So what we will do is we'll go over here. It's basic. We know the here is the place. We know the dimensions of the image. You put this dot out histogram, isn't it? Out image histogram equal to, we say, unsigned char, and that's it, and malloc. What's the size? So basically if you look at this image, you can see that the highest frequency is touching this edge point. When we zoom in, if we think, we may doubt whether this is the highest frequency, or if highest frequency is more than this, we might get it out. So I just want to a small space for breathing. So we say highest frequency value is HRGB plus 10. Why did I put this thing over here? Yeah. So into what we say. Yeah. This of a high value. High value is the length into number of bands. So this dot number of bands. So basically it gives the dimensions, means basically give the memory for the dimension of this out image. And if this is the case with the grayscale, then we have to do just copy this thing, copy here, and after this for loop we put it here. In here we say HRGB same thing. So we say now basically we put an now we have communicated the image data that we are going to dump into the file. Now we have to dump that into file, which has the variable holding the image for that is m. So what we will be doing is we have to communicate the value here. This is the RGB place, so m dot total pixels equal to, we say this thing, copy. So that's it. And we have given the total number of pixels, and also number of rows. We say it as equal to just HRGB, that's number of rows, because it's the highest number of frequency. You can see highest number of frequency corresponds to the number of rows, means corresponds to the height. So that's it. Also we can give a number of columns over here, and also the number of bands, but for the grayscale also this comes to under the same value. So we just keep it here, and we'll put those values outside this conditions. Just copy this thing. Put it here. HGR, number of bands, and HGR. I think that will do the trick. Now we have to say and outside this thing, m dot image equal to this dot out image histogram, and also m dot number of bands equal to this dot number of bands, also m dot number of columns equal to this dot number high value, because you can see that the highest value is the number of columns, the bit corresponding to that. So we put this dot high value, also m dot high value. The highest value you can have, we say it is 250. Let it be a 8-bit image, because we don't need that much fancy images to show we just have RGB there. So we just put 255 is the highest value. That's the value of the white RG, and we have corresponding to high values. We show the white. That's it. So also we have some m header here. Header equal to this dot header, because it's going to be the same thing. If it is color image, the histogram is also of color image. If it is not color image, if this is a grayscale image, then this is also a grayscale image. So basically we have the image and image value to print it out. And I think we have some more issues over here, like we haven't really put the values what should be printed out, isn't it? We say out image is the histogram thing, but we haven't given the value. We just initialized, we haven't given values to it, so we have to put values over there. For that we start an for loop. For first we put the values corresponding to that length, that's high, this not high value, and we just put it over here. Like I just want to make it I and j. This combination I just put it over j. I think that you will find why I put it like this when I write for the loop. And also we have to go like this. We want one more loop because it's 2 dimension. We need another loop. That's the. It is also same as this dot high value. You will understand why I put like this, because the second you will find out, oh, how come this do like this, he do like this, how come he gets another high value, why we didn't need, why he didn't need this thing, because basically we are putting values and putting arranging. Yeah, I'll tell you, like you will understand. And basically we are putting this for another purpose. Yeah, that's it. Like we are arranging this pattern. Like if we'll check what's the high, what's the value, if 256 is the highest, we'll check what's the value of the 255 pixel. Suppose here is it 0, so we will put all this column full of zeros value, and the frequency is corresponding to 255 values 0, so we will put all black here. And when it comes to here, we say suppose this value is 50, so what we will do is we will just put all values as 0 here, and values from this is the 0 1 0 1, values from this place, this 50 to lower, not 50 to 50 minus, that's height minus 50 to height, and this is the correct way it is done. This much length we'll put it as 255, the highest value. That's way we'll do it. So we need one more loop to put that thing. So you guys, I think you understood why I put j over there when we write more. So we need this indicate. I don't want to explicitly say it there. So we'll say number of bands. This dot number of bands, because this dot number of bands is same as the m dot bands, and we'll say k plus plus. Okay, we'll do if there is an if condition. If we'll check if this dot, what we'll do, if this dot high histo the highest value is, because we know the highest value over here, minus I. I think you understood what does that mean, because the if this dot highest value is the height of the image, that minus I, because basically this is the place if you want to aim, that's the histogram minus ith way. So that minus I is less than we say this dot histogram of j plus k. So if it is histogram value is less than or equal, we say we'll put it all what we will put it all 255 the value. So this dot out image histogram into j plus k, and we put some plus over here, and ith into, this is one of the tricky part of here, into this dot high value, yeah, this dot high value into why we put, oh yeah, fine. We don't need brackets over here. I just put it for full question. It's fine. Then we'll put this dot number of bands we have. So that's the mth band. So I know this is a bit confusing, but if you guys really hold on to what I gave, the questions I'm giving here, I think you will figure out what I mean here. It is 255, that goes for the white value. else, I'm sorry, if that's not the case, then we are basically comparing the value. If it is we are comparing, if this is this value, frequency value is higher than, then we will put it on white here, else we will put it on this column full of black. That's what when full of black. So every time we go over this iteration, we will check it out and put it there. Okay, so else we say this dot out image histogram j plus k plus I star, or this dot in high value star, this dot number of bands. So that's basically equal to 0. That's all black. That's what I meant. Here it's all black, then this value is all white. That each and every pixel we go through like this. So basically we have returned data to the image. Now we say m dot write image. So basically that's what we need to give, but I am proposing some changes in things that we have done here. Like basically we have to write this image, so like we have to use this image dot write image a lot of times. So I prefer we have some naming conventions over here. We put something like this. We say int some k, that's it, and we say arg of k, also we say k something over here, so k. So I think that does put the saving the image. So also here we put some arg of k. Here we need to write also we will put it here in the k. Is there something over here? fp of, let me check it over here. That's r of k. So then I think we also make change here histogram int k. So we put that, after writing we put that k over here. So basically we have written the image to a file. Also we need to make that changes over here. indicate and that's comma indicate. So that does fit the. So basically we have done it. And also we say here we read an image, that's first name, also so basically we have read the image. So we can also write that. Okay, we need the second name to write that. Okay, we don't want to write it, we just say we want to just calculate the histogram. Histogram, and that's the name. Just check it out. That's this name itself. So basically I think we are almost done with this file. I am sure whether there are some errors over here. I am just supposing there aren't much errors. So I think it's fine that we can proceed to check whether things do work. Okay, so let's start. We can go over one more thing to open. Yeah, that's test dot a. Here we say so one dot post one dot pp, then ppm. Just go here, yeah, cd, make a skill, c learning, and that's image processing, and sh test not sh. So we had some errors. So member has no member calculate histogram. Okay, we'll check it over here. What was the problem? Calculate histogram. We just go over here. Oh, that was spelling mistake. I'm sorry. I don't know what's going really. Some error is going on. Yeah, that's in values of this non-member function. Oh, I get it. Oh, we because we forgot something like this over here. So we just put it over here. I think it might just work well now. So we got some more errors. That's in here, color histogram, and in here, image. What's it? Oh, we got more error over here. I think histogram this dot image. I think I've what's that place? We forgot something, some I over there. I think so. Oh yeah. That's the place. Basically, we forgot an either. I suppose so. We'll just put it over here. This not image not I. Just clear it out. Again, we have small errors over here. That's expression of 137. Oh, we forgot a semicolon over here. Here there's something missing over there also. Yeah, that's fine. So again we just I think we got the image done. Writing image to hist host post. That name is weird. Okay, technical skill, and where was that? C learning. Image processing. Yeah, so basically this was our image, and we wrote the hist post. We'll just check with this post 1.pgm as test. Post 1.pgm and hist post.pgm for trying. So it was also written. So we'll just go here and check it out. Also look at this. This basically has black, brown and white image, so it should have 4 lines. Yeah, look, I think the first one, the one line is there. You can, if you zoom out here, I'm sorry, you can, if you zoom here, you can see that 10 difference that I told here, and there is a line here, and all things are here, 1 2 3 4. So basically that's cool. So I think this is the point. I think I was thinking, okay, that's fine, and we have done a bit of programming over here. Okay, yes, and this is the end. I think I wish you guys understand something from this and make it out. Also, I'm putting the link for this code in the description. Okay, thank you guys. Love and peace.